Okay. Then, whatever doesn't cancel, we set equal to 0 from the numerator. So what two things are we set, or one thing, whichever, are we setting equal to 0, Jenna?
I did x minus 3 equals 0 and then x plus 2 equals 0.
Yeah. So both of these, so -3 and -2. So, Justin, if you look back at the graph for h of x, where did the zeros happen at?
X equals -2 and x equals 3.
Yep. X equals -3 and +2? Or no, wait a minute. Did I write that down wrong? Yeah, I did. That's positive. Just kidding. So yes, x equals +3 and x equals -2, right? Yeah. Okay, good. Then constant term in the numerator over constant term in the denominator. Becca, what are those constant terms here? What doesn't have variables with them?
-6, -10.
Very good. So that's what you do. You put -6 over -10, and that'll reduce to 3/5. -2 will go on above those. And then what do you suppose the y-intercept is, Kendrick? Yes. Kind of hard to tell from the picture that it's 3/5, but it is about right here. And I know it's supposed to be the same as this, so therefore it must be 3/5. Good. So I don't think we have to keep doing those. I think you got that. So if the constant term in the numerator and the constant term of the denominator, if it's undefined, then there's no y-intercept. If it's a number, then that's what the y-intercept is. And then when you set the numerator equal to 0, the part that doesn't cancel, then that's going to be your zeros, where it crosses the x-axis, the x-intercepts. All right. So let's look at this next part. Okay, it says, state the information you found in table 338 to respond to the following questions. That's what we just talked about. So how do you determine the restricted values? You set the factors in the denominator equal to 0. And solve. It's supposed to be an and. How do you determine the domain? Well, the domain is -infinity to infinity, except for the restricted values you just found on the first one, where the denominator equals 0, and the bottom equals 0. From the equation of the rational function, how do you determine the zeros of the graph? You set the numerator, so the non-canceling factor, so one that's not on the top and the bottom of the numerator, for the top equal to 0 and solve. And then from the equation of the rational function, how do you determine the y-intercept? The y-intercept is the ratio of the constant terms, the ones that don't have an x, of the numerator and denominator, top and bottom. That's all stuff we did. Now we're just writing down what it is we did. Just so you have something to look back on and go, oh, that's what we did. Okay. They both look the same, so it doesn't really matter. Let's do g of x. That's the second equation. It's just a little easier to factor. Do this whole column. This one. Do that. The red one. And if you need to look up above it, it tells you how to do all that stuff. Okay, because we're going to run out of time, I'm going to go ahead and start. So, first thing we're supposed to do is factor it. Oh. So that factors into x plus 5 and x minus 2 on top, and then x plus 2 and x minus 2 on bottom. So the restricted values are where the bottom equals 0. So that's at positive 2 and negative 2. So when I do the domain here, it's everything but those. Then for the zeros, well, I look up here at what cancels. I don't use that. I use what's left over in the numerator, which would be x plus 5, and I set that equal to 0. So the zeros of the function, or 0 in this case, is x equals negative 5. And then the y-intercept is constant over constant. So negative 10 over negative 4. Which is 5 over 2. And that's the y-intercept. So. And you should be set for day 35 homework now. So tomorrow you'll work on day 34 and 35 homework.